You can compile the function by pasting or typing the function in SQL Plus followed by a slash, or by typing it in SQL Worksheet in SQL Developer and then pressing the Run Script button. We will see that shortly in the demo. If you have saved the function in a file, say getempcount.sql in the c:\demo directory, then again like procedures you can call that with the add sign followed by the full path name of the file and hit enter in SQL Plus or by clicking Run Script in SQL Developer. You can also compile an already existing function like getempcount by doing alter function getempcount compile. On the topic of compilation, let me briefly talk about native compilation and PL/SQL optimized level setting, which can help improve the performance of your function. I will also show you how to enable your function for debug. We talked about these in detail in the procedures module, so I will not go in much detail over here. Native compilation compiles your code in the native C mode versus the default interpreted mode, which allows Oracle runtime process to directly run the code without interpreting it, thus improving performance, sometimes considerably. You can set the PL/SQL code type, which controls compilation level, to native using alter session set PL/SQL code type equal to native, and then compile the function as alter function getempcount PL/SQL code type equal to native to compile it in the native mode. PL/SQL optimized level is another parameter which can make the compiler work hard to optimize your code during the compilation process. For instance, avoiding unnecessary assignments and computations, inlining program calls, and other optimizations. The higher the level, the better it is, but I recommend keeping it at least at level 2. You can do it for your session by the command alter session set PL/SQL optimized level equal to 2. After this, the programs like functions and procedures you will compile in your session will get this optimization level during compilation. These are a couple of nice ways to optimize your code and make it more performant without having to involve any work or code changes at your end, and I highly recommend using these. Lastly, at some time or the other, you will have a need to debug your program unit. You cannot set breakpoints and debug using SQL Developer unless you compile your program unit in the debug mode. Alter function getempcount compile debug will compile it in the debug mode. You should do these only for the programs you need to debug and then compile them back in the normal or non-debug mode, as the debug mode can slow performance and also cannot take advantage of native compilation. Like the procedures, compiling functions can lead to errors and warnings too. The discussion of errors and warnings we had for procedures is also applicable for functions, and so we would just briefly talk about them over here. Some conditions which can raise errors are syntax errors or invalid object names being referred in the function. Starting with version 10G, Oracle can also give us warnings. The warning categories are severe, performance, and informational, and these categories can be enabled, disabled, or treated as errors. So the compiler can help us catch informational situations like unreachable code or give us performance warnings for unnecessary bind conversions. The commands to set them are the same as we saw in the procedure module. For example, we can use alter session commands to set the warning levels to be enabled for the session. We can use the alter function command to compile getempcount function specifying the warning levels as enable for performance, error for severe, error for the PLW warning code of 06002, and reuse the settings from the last execution for the remaining parameters like informational, which are not specified. So as you can see, Oracle gives us a lot of control and flexibility in specifying these. Warnings or errors, if any, can be reviewed by using show errors command in SQL Plus and SQL Developer. Another way of setting warnings is using the dbms warning package. Call dbms warning dot add warning setting category all enable session will enable it for the session. Executing the function is a little different than executing a procedure because a function returns a value and we need to catch that value somehow. We can call a function from a PL/SQL block or another subprogram like a procedure or a function. So first, we see a code snippet of using an anonymous block where we have declared a variable lReturn of type number to hold the results of calling the getEmpCount function. Since the declaration of the function says that it returns a number, we declare a number to hold its result. The name can be anything we want to be, and it does not have to be the name of the variable returned from inside the function. We could have also declared here lReturn as of type varchar2, and Oracle would have implicitly converted the returned number value to a varchar2 and assigned it to lReturn. But of course, it is extra work we are making Oracle do, and we should avoid such unnecessary conversions. If we had declared lReturn as another data type, which Oracle cannot implicitly convert the return value to, say a date, then Oracle would have given an error aura-06550 expression is of the wrong type. Inside the execution section, we invoke the function and assign its return value to lReturn. This is the same way we would have called this function in another procedure or another function. Running this block will give us the return value, say 1. Functions can also be called in SQL statements if they qualify certain conditions. We will talk about those in detail later in the module about calling Oracle functions from SQL. So we can call our function getEmpCount as select getEmpCount from dual to give us the same result of 1. These are the most common ways of calling functions. Let us look at another way of calling functions which is not that commonly used. We can also call a function using the exec or execute command using bind variables as assignment targets of the function call. Bind variables are variables you can declare outside of PL/SQL using SQL commands for basic types like varchar2, number, date, etc., as well as ref cursor types. Then you refer to them later with a colon sign in front. So in this code snippet, we declare a bind variable as variable lReturn of type number. Now we run the statement exec lReturn equal to getEmpCount. Execute lReturn equal to getEmpCount is another equivalent way to call the function getEmpCount in SQL Plus or SQL Developer Worksheet to get the result in lReturn bind variable. After this, we can see the value of the bind variable using the print lReturn statement, which will give us a value of 1. In the next code snippet, I have shown how you can refer to a bind variable declared in SQL Plus or SQL Developer inside a PL/SQL block. Here again we use the colon in front of the bind variable name inside PL/SQL to refer to it. Here we have assigned the value returned by getEmpCount to lReturn. Then outside the PL/SQL block, we can get its value by print lReturn statement. This is how you can use bind variables inside and outside of PL/SQL blocks. This way of execution of functions, however, is not very common, but I just wanted you to know about it if you see it in some code you are maintaining, or you have a need to use them this way.